Hello everyone and welcome back. Today we are going to be learning about object detection. So what is object detection? It is a technology of deep learning where things, humans, buildings and cars can be detected as objects in the images and videos. So object detection is merely recognizing the object with a bounding box in the image. It's just like used in CCTV cameras or surveillance ones. Applications of object detection. So object detection is applied in numerous of territories of image processing, including picture retrieval, security, observation, computerized vehicle systems, and machine investigation. Tracking object. So, an item or an object detection framework is additionally utilized in tracking the objects. For instance, tracking a ball during a match in the Football World Cup. So, tracking a swing of a cricket bat, tracking an individual in a video, or object tracking has an assortment of uses, some of which are surveillance and security, traffic checking, video correspondence, robot vision, and activity. Automated CCTV surveillance. Typically, CCTV is running inevitably, so we need a huge size of memory framework to store the recorded video. So, by utilizing or using an object discovery framework, we can mechanize the CCTV so that events in that few items are detected. At that point, the record is going to begin. So, now we're going to be moving on to the coding part. So first of all, we're going to import a library called Google Colab.patches from CV2 IMShell. We're going to import our CV2 library, which is computer vision, and we're going to import numpy as np. Then we have our cap, which is our variable to store our video, the content car video. So now this is the size of the video we want to put, that the minimum width direct is going to be 80, minimum height direct is going to be 80, count line is going to be 550, means 550, and detect we're going to put in 0 because we're going to let the computer detect itself. We have our offset and our count, which is 6 and 0 respectively. Then we have our algo is equal to create background subtract mog2. This is another variable we are also going to use. So we're going to def handle center for x, y, w, h, and x1 is going to be in int x by 2 and y1 is going to be int h by 2. And cx is going to be x plus 1 and cy is going to be y plus 1. Then we're going to return these two variables, and what's going to happen that our computer is going to get activated to start detecting the objects, which is the cars. Now we're going to have a while loop. So while 2, the red frame is going to be cap read, means we're finally gonna start detecting it. We're going to make it gray color. We're gonna blur the image a little bit, and here we use algo, and here we can have dilate, which means making it a bit more thicker and bigger. And the kernel is going to be get structuring element morph ellipse 55, which means this is the process of how to detect and create a box around it. Then we have dila data and morphology x dilat cv2 morph close kernel, and here we also have the same thing, but it's gonna be dila data morph close and kernel. This is basically to detect the cars and the object. Then we have our contour. Contour is basically when you detect the center of it. So for contour, and then we have our variable edge from the earlier one. And CV2 find contours dila data cv2.retrieve cv2.chain approx simple. So here we're actually going to find the contours, and here we have our line, which is going to be frame 1 25 count line, 1 200 count line, and then we have 234 212 and 190 and 3. Now we have another for loop we have over here. We're still in the while loop. So it's going to be for IC in enumerate. We're going to have contour. X, Y, W, H is going to be equal to bounding rect. Then we have this validate counter. And it is like W is more than min with rect. And H is more than minimum height rect. So now if not validate counter, we're going to continue it. So cv2.rectangle frame 1 xy, and then we have xy wh and 00255. This whole code, you can say, is to detect the red line around the cars, and this one also. So if you can see, it's for xy and detect For x, y, and detect, we have if y it's more than the count line of offset and y is also more than the count line of offset, count is going to be plus equal to 1. So now we have our CV2 line. We are going to get the color of the line, get it activated, and detect remove xy. We're now removing the variables called xy. We're going to print vehicle counter and STR count. Here, this whole line STR count is going to tell us how many cars are actually detected. We're going to put text in a frame, vehicle counter. Then we have the CV2 font Hershey Simplex. These are one of the many fonts in CV. And then we have I'm show frame 1, means we're going to show the frame 1. We're going to wait key for 13 seconds, and then we're going to break. If we wait for more than 30 is to 30 seconds, then we're going to break the loop, and we're going to destroy all windows and cap release, which means our video is now going to be played. So as you can see, if I scroll down, the vehicle counter is soon getting detected. And if I scroll all the way down, let's see how many total videos are detected in this 3.5 minutes video. So as you can see, there are 218 vehicles detected in this video. So thank you so much for watching, and I will be seeing you in my